Hello, and welcome to this next installment of a video series with ASCO. I'm Amara Rozgis with Consulting Specifying Engineer, and I'm happy to be here with you today. We're talking about a lot of different topics with Russell Senesak. Russell Senesak has been with Schneider Electric for several years. He originally started with APC in 1996 and has had several positions. He's moved around quite a bit through sales, product management, and strategy. His concentration, however, has traditionally been in mission-critical applications, specifically with data centers and edge environments. And then within Schneider Electric, Russell's been recently focused on market trends, disruptions. He's collaborating with the R&D team, and he's solving a variety of challenges faced by consulting engineers. Just recently, Russell broadened his focus to include the rapidly developing new energy landscape, which includes electrical source management, distribution, and load prioritization. Thanks for joining me today, Russell.
Thanks for having me, Mara. Happy to be here.
Yeah, so we've been talking about the topic of power and energy and batteries. And we know that the trend is that more folks are focused on wanting batteries first. I mean, that's the approach. And it might be economic reasons, it might be sustainability reasons. And the consulting specifying engineer audience in a recent research study responded that there needs to be governing standards about how that should be deployed. In fact, 87% said that, yeah, there needs to be governance. Can you give us some insights of what was applied to automatic transfer switches and how we should be thinking about those requirements for battery energy storage systems?
Yeah, absolutely. I think it's I've said in some other prior podcasts, I think, just highlighting the pace of which we're seeing change inside this category right now is unprecedented, right? And it's I give these analogies to the telecommunication industry where every 12 to 18 months, there's a new iPhone, right? That's ready to come out onto the market. And if you look at the advancements of like what a flip phone looked like a decade ago, right, versus what it looks like today, technology moves fast. And I think that there would be a general statement to say that we're actually moving faster than our traditional codes and standards cycles typically go. Because honestly, in this electrical space, there hasn't had that need to be able to go faster because quite frankly, the technology wasn't going as fast. And so if you look at like a traditional National Electric Code cycle, it's 3 years. And I think certainly we would agree that, over the course of 3 years right now, you're going to see quite a difference in technology. And so this is a very specific deep dive discussion to say, hey, listen, we're seeing now with the reduction in cost of battery energy storage systems, with all of the drivers we've discussed in the past around, hey, I want to be more sustainable. Hey, there's money out there for me to be able to take advantage of. Hey, there's a some sort of resiliency requirement now that wasn't there before, like a power utility shut off or a weather event or something has happened. All these reasons are driving the need now for the battery energy storage to be there. And then lo and behold, if it's sitting there and I want to call on it instead of a generator, or maybe I want to call on it first before the generator, now all of a sudden it's put itself squarely in that, hey, if you're providing backup power or emergency backup power, are you being governed by the same level of codes and standards that we have traditionally put on things like generators and transfer switches, UPSs, et cetera, in the past? And quite frankly, the answer has been no. We don't have a set of standards that are there today for us to be able to govern to. And so when we had asked this question in that consulting specifying engineering survey, you can see again, like the overwhelming majority came back and said, but we should, right? Because why do we create all these codes and standards and rigor around emergency power systems, for the last 2 decades with generators and ETSs and UPSs, et cetera, only to have these new sources show up and go, it doesn't matter. They can do whatever. So I think it's the market is speaking very clearly to it, and I think it's something that UL and others are taking extremely seriously now. Is how not only do we catch up a little bit to some of these things that have made their way in the market without having a lot of rigor around them, but also how do you get in front of this now so that you're you're anticipating how these new sources and loads are going to work together in a very resilient and robust way moving forward.
Okay, so what are these new standards? Can you give us a little bit of information about them and
Yep.
about their relevance?
Yeah, so hats off to UL for really stepping up on a lot of these now. So the first one that I can speak of that'll be the topic of today is this new standard called UL 3008. So the first thing I would do is I would pause for a second and just kind of give a little bit of reflection as to like where have we been in this space, right? As it comes to a switch that is required to be able to get us to some sort of emergency power. So in the past, as we've talked about, that's a transfer switch. So an ATS or a transfer switch is very clear in UL 1008 on how it's constructed, where the components have to sit inside the system itself, like they can't be in separate rooms, how they're connected, where they come from. They can't be a bunch of different manufacturers that are blended together. And then most importantly, how are they tested together as a system inside that box? And so there is a very complete and robust set of testing requirements, performance testing around temperature rise and static and heat and all kinds of fun stuff that is way beyond my pay grade when I look at these reports. But it's very robust, right? And it's continued to be more robust over time. It's not like we created UL 1008, 30 years ago, and it's been the same for the last 30 years. Every year, every 2 years, it goes through a cycle of learning, technology advancement, and it gets better. But as we've talked about in the past, the general idea here is that you have a battery, you don't need a transfer switch. You can't even use a transfer switch. What you need is an isolation switch. So the idea here now is that we want to take what we learned in 1008 and apply it to 3008, because we don't need a clean sheet of paper. It's not like we got to go figure out a flux capacitor or something that just came into the marketplace. We have no idea. Like, we've got decades of experience on how to do this with a transfer switch. We need to take what we learned there and give us that head start, where 80% of it applies to an isolation switch. But because we're not transferring, we're isolating, we got to take out a few things, add a few things. That's like the 20% to be able to kind of complete this. So the idea here now is that obviously you'll recognize that it's 008. And the general idea for that is to be able to help the market understand now that it's a 1008 for transfer switch and it's a 3008 for isolation switches. The 3 is not random either. If you look at what UL is establishing in these new energy landscapes, and we talk about distributed energy resources, this is usually where the term microgrid gets tossed around. So the 3 series of standards within UL all relate to this new energy landscape, right? So it's one way of thinking about kind of like there's a traditional, and then anything that starts with 3 is kind of a new energy landscape thing, and then the 008 is meant to be able to relate back to the transfer switch that's there. So as I talked about, without wanting to necessarily read you the things that are on the slide, but I think it's important to kind of understand like some of the key salient points that come through here, because the reality is that you could go get some type of controller and go get a couple contactors, and you could wire them up, and you could make isolation, right? I can make something turn off, turn on, turn off, turn on. It's very simple to do. But to ensure that it's robust when it needs to be called upon, because remember, that thing could sit there for like years and never be called upon. Then all of a sudden, some sort of hurricane or natural disaster or whatever comes along, and suddenly you need it. And then if you need it, it's not there. There has to be that level of endurance that we've been able to prove out with generators and testing and procedures, et cetera, for years. And so it talks about everything needs to be based in an enclosure. It can't be all in separate rooms, all wired up differently. Like what happens if somebody cuts a wire kind of scenario. All that has to be factory tested, factory connected, factory installed, same manufacturer. There needs to be a testing procedure that ensures that it's been tested not only to work in normal circumstances, but then you also go through these emergency circumstances of what if the building's on fire, what if it's a seismic event during an earthquake. And so there is, like I said, a very robust and rigorous test sequence that's already been developed and that we've learned from that drives 1008 and now that's being applied to 3008. So it's something now that the market is learning about. This podcast is very much part of that education process. It's relatively new for UL, and the intent here and the strategic desire is to make sure that as we drive that towards that more sustainable, more carbon friendly, more economic, all those things that we like about adopting solar and storage and fuel cells and all those other things, we can't do that at the expense of resiliency. We have to make, we've done such a great job with safety and reliability of the power systems over the decades. You want to take that, and it's an and statement. It's not an or statement. Like, we can't have sustainability and or have resiliency. It's got to be have sustainability, and we still have the same level or even more robust level of safety and reliability that we've come to rely upon.
So what are those 3 R's again, Russell? Russell? 4 R's. 4 R's.
Russell, that's 4 R's, right? Yeah.
Yeah.
The resiliency and robustness and the rigor, right? So those are the R's that I think that we really need to make sure that while sustainable is very important to us, can't lose sight of the R's.
Got it. Thank you so much, Russell, and thank you for teaching us about all of the R's today. And we will see you on our next video session. Thank you so much for joining us, and goodbye.